Hi there. Now for this question we're given that x equals sec squared 3y, where y is between 0 and pi upon 6, and this is measured in radians because there's no degrees here. And we've got to find dx by dy in terms of y for 2 marks. And then in part B, hence show that dy by dx equals 1 all divided by 6x times x minus 1 to the power half for 4 marks. So if you'd like to have a go at this, I'll just give you a moment to pause the video. When you come back, I'll go slowly through the work solution, or you might want to fast forward. Okay, welcome back then if you had a go. Now for part A, we're given then that x equals sec squared 3y, and we've got to find dx dy in terms of y. So all we need to do is differentiate this with respect to y. But first of all, I'm going to write this in the form x equals sec of 3y, and it's all squared. And to differentiate this is going to mean that we're going to need to use the chain rule. I've got to be familiar with differentiating sec of an angle. And I've just given you here something that you should be familiar with. If not, you generally find these results in your formula book. Check it out, okay? That d by d theta of, say, sec theta is equal to sec theta tan theta. But with all trig functions, if you've got a constant with your theta, let's say that constant is a, the differential with respect to theta of sec a theta is a sec a theta tan a theta. We get this constant at the front here by using the chain rule, so do check that out, okay? Now working on that assumption, then to differentiate this, dx by dy in other words, what we're going to have to do is apply the chain rule on this. In other words, I'm going to say let's say let x equal t squared. So I'm replacing the sec 3y with a t, x equals t squared. So we better say that where t equals sec of 3y. So when it comes to differentiating this, I'm going to say that if I get dx by dy, it's exactly the same by applying the chain rule as dx by dt, as long as I multiply this with dt by dy. It's as if these dt's cancel, leaving me with just dx over dy. So on that basis then, going back to here, dx dy is equal to dx by dt, and if I differentiate x with respect to t, then I'm going to get 2t. So we'll put 2, and instead of t, we know that t is sec 3y, so that's 2 times sec 3y. And we'll close the bracket. So that's dx dt, the first part here done. Now we've got to multiply it by dt dy. So we need to differentiate t equaling sec 3y with respect to y. And we can pick up on this result here. The constant is the 3. So what we're going to get then is that this is equal to 3 sec 3y multiplied by tan of 3y. So it's just a question now of tidying this up. And if we tidy this up, we end up with the 2 times the 3 here being 6. Then we've got sec 3y times another sec 3y, so that's going to be sec squared 3y. And then we've got tan 3y. Okay? And so we've got dx dy expressed in terms of y, as was asked. Now for part B then, we've got to hence show that dy by dx is this fraction here. And to do that, I've got dx dy, so it'll just be a case of inverting it to get dy by dx. But I think we've got a little bit more to do than that, because we've got dx dy in terms of y and we've got to get it in terms of x. Well, I'm looking at what we've got at the moment, and I can see that sec squared 3y is in fact x. So really here we've got 6x. It's just a question of trying to convert tan 3y in terms of x. And I can get a link if I think of the fact that this identity we should know already, and that is that if you've got, say, 1 plus tan squared of an angle, let's say we call it theta, it's equal to sec squared theta. Okay, should be familiar with that one. So if we rearrange this for tan squared theta, therefore tan squared theta must be equal to sec squared theta minus 1. So if we apply that to what we've got here, tan of 3y, replacing the theta with 3y and square rooting both sides, it must mean that therefore tan of 3y would be equal to the square root then of sec squared 3y minus 1. So that's sec squared 3y minus 1. But we know that sec squared 3y is x, so tan of 3y then must be exactly the same as the square root then of x minus 1. So if we just border this off here, okay, we can now say then in part B that dx dy, instead of it being equal to this, it's going to be equal to 6x, okay, for sec squared 3y, and tan 3y we've just seen is the root of x minus 1. So therefore it follows from this that dy by dx, okay, therefore dy by dx is going to equal 1 over this, 1 divided then by 6x, and instead of the root I'm just going to write that then as a bracket x minus 1 to the power a half, just so that I get it in exactly the same format as we had up here. Okay.